Welcome everyone to the extended lessons in Python. So this one, I'm going to label off right away and say that this is something you will need, seriously, not probably, you will need to know for the test. And today we're just going to talk about threading. As you can see, I've already put the code up, and what we're going to do is run through it and break it down for you and then put some comments in there so we know what we're doing or know what's happening. And basically what I wanted you to show you is how to thread. And threading in a lot of other programming languages is difficult just because it's very verbose. But thank goodness for Python. Python always simplifies everything and lets you do it. In fact, I was going to do this in C# in my intro class and I ended up pulling it out at the last second, just because, again, C#, if you look at how you set up a thread in the beginning, it's I don't want to say it's mind-blowing, but for students it's numbing. But once you start reading it, oh, this means this and this means this and this means this, and oh, okay, I get this, and okay, so on and so forth, it all kind of makes sense, but you kind of have to get to that spot. With Python you don't have that problem. If you don't know what threading is essentially breaking a program into mini programs, and then you can throw them on different processors on your machine. So way back in the day, a lot of times you didn't do a ton of threading, but now that you have like 4 processors in your PC, might as well try to maximize the usage of the processors. And as we'll see today, it doesn't naturally do this for everything. So the first thing we're going to do is bring in our library. So we're going to bring in a time library, which is not essential. And all of these should be in your original, what do you call it? Your original packages. You shouldn't have to go to the view, other windows, Python environments. Remember how we loaded you either had packages or pip, which is essentially packages itself, and loaded those. You shouldn't have to load any of the new ones, and they should come in and you should be able to see them right away. Time is a very normal one. Threading should be a very popular one. I think I'm using 3.6 here. I'm not 100% sure, but I'm pretty sure that's what I'm using right now, and it should be available. Okay, now the first thing I'm going to do is actually undo this. So I am going to Control X this and put it down here, and I am going to undo all this. And you might have to, I don't know if I've already said this, but you might have to pause the video from time to time so you can catch up on the typing. As you can see, right now it's kind of a mess because we have no comments here. We just put our first comment in. So what I'm doing with this first step is just pulling a time from the system clock off and setting it equal to old time, which is essentially the same thing I'm doing here, except briefly later. And then this guy in the middle is a sleep function. Now, sleep functions or methods, what they like to do is, and they're usually available in most programming languages, is that they will essentially turn off the action for a couple seconds. In this case, we set it to 2, so we will stall for 2 seconds, or essentially put the processor to sleep, so to speak, which you're not really doing it, but it's giving the illusion that you're actually turning off the processor, and then it'll come back on and start again. And so the difference between this time and this time should be 2 seconds, because that's what we put in here. So that's why I subtract them and then print them out. So just as a test case, I think everything looks looks highlighted out. Let's go ahead and run that real quick. And you should have to wait for 2 seconds. And notice there's a little bit extra time because it takes time to actually process the time. We will get usually I'd be surprised if you get 1.9999. You're probably always going to get about 2.000, and then or 2.001 or something like that. It should be less than that. It shouldn't take that much time unless you're working on a really old PC or laptop. So it's not going to be a perfect 2.0, but it's good. And the reason being is the second process actually turns it. And to be honest, the sleep functions are not necessarily always 100% perfect. Okay, so let's keep going with this. So at this point, this time, we really haven't done, actually before I forget, I'm going to say time it takes to go from first taken time to second. But anyways, getting back to it, we really have not done any threading whatsoever. Really what we just did there was to kind of show you the methodology that we're going to be using. If you ever want to use the sleep, you can go ahead. Some people balk at sleep, and the reason being that it can be a little bit of a security issue. Most of the time, you're not going to have a problem with it. So anyways, why did I show you sleep? One, to show you the old time, new time thing, and to show that it's working correctly. But also, there's times when you do want to stall something for a second or a half second or something, especially when you start moving pictures around or something like that. You might actually want that. And so go ahead and keep that in your tool chest. Okay, so let's get back to what we really want to do, which is test out this threading. And I actually have 3 different ways to thread. I'm going to go to I have 3 different things that's doing the same exact thing, which is essentially spawning an object, or 5 objects in this case. And I spawn them 5 different ways, but really it's doing the same thing each time. I just wanted to make sure that you understood the equivalency. Now, this first set I'm using threading, the third set I'm using threading, and the reason why I'm doing it is sometimes that first set generates a little slow, so I didn't want to artificially make the threading seem super fast. So I'm going to go to the second part first. And again, feel free to type all this stuff in. We got the old time, new time, time difference, and print time. That's exactly the same as when we did the sleep function. The only new parts of this is we are going to spawn 5 objects. And spawning objects always takes a little bit of time. Objects make systems a little bit slower. You wouldn't want to do a database with objects necessarily, because you'd do slow it down. So I wanted to pick something that would take a little bit of time, and then once I'm inside of it, I'm going to actually what was I going to do? I am actually, once I'm inside of it, I'm going to slow it down even more. Note what I'm doing here. I'm just making 5 different spawns, and I'm giving them numbers. So I'm being very specific with their names. So when I create a new object or instantiate a new object, that they're going to be called spawner 1, spawner 2, spawner 3, spawner 4, spawner 5. Later on, we're going to do a slightly different method, but that should not speed it up. The reason we'll speed up is the threading. So what we need to get to from here is to understand what's happening in Spawny. And so let's go ahead, because remember we set up here from Spawny import Spawny. Well, what's in Spawny? we have a simple class object. If you guys forgot, this is whenever you do a class, you have to build this constructor, and you have a self. Then all we do is take go to 100,000. Don't do it less than this. Because you won't see the advantage of threadings. I would say don't go more than this because you don't want to sit there and make a sandwich and file your nails to figure out, and then 10 minutes later it actually finishes it. So I found that 100,000 works relatively well. Because for speed, so it doesn't take forever, and also showing you the difference. But if you go up more and more and more, so in other words, I increase it 500,000 or a million or something, you start seeing a dramatic difference in what the threading's doing. And then, of course, we have underneath here, we're just going to add 1, so it's going to go 1, so it'll go from 0 to 100,000, and that's just essentially to slow this guy down. So that we have a measurable time, because if you have a speed demon computer, spawning an object itself is very quick, and those numbers that we're going to generate from the time are not, that might be fictitious. So in other words, there might be a stall somewhere else that's causing the time difference, and not the actual difference between one methodology of executing 5 objects versus another 5 objects threading. Okay, so if you forgot how to do the classes, remember all you have to do is do a project, add new item, Python class, and then call it spawny down here. And then it'll automatically put it in the topic. Remember, if you've created it late, you can always do a drag and drop of it. So in other words, let's say you created a spawny, but it's not in here. You can actually drag and drop it on there like we've done before. Either way works. Now they're associated, and we're ready to go, and that will spawn 5 objects. And I'm going to put individually here. So let's see what I did down here. And I know it seems a little odd. What I'm doing here is, again, with the time part of it is the exact same. So these lines were what we did before. And now this is going to be an explicit spawn. But as you can see here, we're using the term thread. So we're going to say here, each instantiation gets its, I'm going to say, own thread. Or it's going to be broken up and then parallel processed together. Now you'll see target spit out. This is, I wouldn't say spit out is a standard, but target usually is going to be looking for a function. And that's kind of the easiest way to do it. So notice how easy it is. We set up the thread here, we start the thread here, and we actually make it run there. So where is spit out? Well, if you were already typing in, you probably know it exists up here, and it's just a simple function which spawn and append spawning. Now, why do I do it this way? It's easy. So I create this spawner array this time, and instead of explicitly writing the 5, 1, 2, 3, 4, 5, I just said, okay, forget it. I'm just going to create a list and append these guys, or add each one of these newly instantiated objects into the list. So all 5 of these guys here, 1, 2, 3, 4, and 5 will we'll start a thread and run this function in that thread. And inside that function, it's going to spawn a new spawnee, which, was doing this piece. And so this is explicitly doing it. We're just doing that and running it each time. Now you can actually speed that up with a good for statement. Now, believe it or not, for statements will slow you down a hair doing it this way as opposed to the explicit way of doing it. But as you'll see, it's not going to be terrible. So now, again, one more time, these 4 pieces are all good and ready, and we've done before. The only thing new is this, which isn't really new because this is what we explicitly said down at the bottom. And we're going to do 5 of them. So all we have to do instead and just say I in range and run this thing 5 times, right? So this is kind of like a while loop or for loop in itself, except it's kind of, grabbing these guys and doing them all appropriately. And it should work. So this is going to be an easy loop. And I think that, I was rethinking something there. So we're going to run this. And again, our thread, it should create our 5 threads there. And so it should be equivalent to this. Now let's see the times. Now remember, thread is first, non-threaded is second, and then thread is third. So if we run this, we first find the error. And 5. Oh yes, I do. I always forget to delete this second set of quotes, single quotes. And so the first one you see is actually the 2 seconds that we did with just a time. But then you'll see 273, which is the for loop, and then 1479, which is the unthreaded loop, and then 238. This is a pretty significant difference. You might not see this great of one when you thread, but this is what works again. When you rerun this, you'll get different times because remember, different things are happening on your process. So again, we get to 242, 1500, 296. These you'll get a little bit of bubbling, meaning that then you won't always get the right answer and they'll flip-flop. But the big thing, what I want you to notice is that middle one, which is the non-threaded piece, is going a lot slower. I'll do it one more time with that. And then so the end product is do you have to thread everything? No. That's a non-issue. You don't have to do a threading if your program's running fine and looks great and works great, because threading, to be honest, threading opens up another possibility of insecurity. It can fail. Every line of code that you put in is a line that can fail. So if you got a simple piece and it's working great, don't thread it. If you're finding significant lag, that's when you're going to be thinking about, okay, I don't want people tapping their fingers and wondering if their app or whatever is not working. Then you start throwing that in. If it's a real-time type of executable where, like in games or something like that, where that's driving people nuts, yes, you then start thinking of threading. So this is one way to kind of optimize and make your programs work a little quicker. Hopefully you find it helpful.